I realized that we didn't really cover bounded integration that well, so I'm just gonna make a quick video of me doing an example of bounded integration just so we're all on the same page. So I'm going to be looking at number 10 on page 319. So page 319, and I just randomly picked this one, and I have not gone through it yet, so we'll see how it goes. So number 10 is we are integrating, the boundary is 0 to 3, and the function is 3x squared plus x minus 2 dx. Right. Okay, so what this is looking like, actually, we'll just skip that. Let's integrate this first. So what we want to do first is integrate the function. So we have addition for all of these. So I'm just going to be doing sum and difference rule here. So I'm going to go, actually we don't write that. So since we're integrating already, I'm going to do 3x 2 plus 1 over 2 plus 1 plus x 1 plus 1 over 1 plus 1 minus 2x, we're just going to add an x there, plus c. And when I have integrated it, but I have a boundary, I'm going to put a line at the end here and go 0 to 3. So what this does is this indicates that I've integrated it. I just have not put in my boundaries. So simplify this down a little bit. This is going to be x cubed, right? Because this is 3. The 3 can cancel these out. So x cubed plus x squared over 2 minus 2x plus c. Okay, so this is where it gets a little bit tricky. So I'm going to sub in 3 for x and then subtract subbing in 0 for x. So basically what it's going to look like is 3 cubed plus 3 squared over 2 minus 2 times 3 plus c. And now we're going to subtract the same thing. We're going to use the same function, but 0 as our x. So 0 to the third plus 0 squared over 2 minus 2 times 0 plus c. So what's cool about this is you have c minus c every single time you do this. Every single time you'll have a c minus c. So you can actually just ignore the c's when you're doing this. So you'll need the c up here. You need this c. But when you are actually trying to solve for a real number that's bounded, in an interval that's bounded, you do not need to write the c's because they will always cancel out. So if you look here, this will just go to 0 because you got 0 plus 0 minus 0. So that's just 0. Pretty straightforward. And then over here, we're going to have 27 plus 9 over 2 minus 6. We want to make this kind of pretty, so we're going to do 27 times 2 is 54. 54 over 2 plus 9 over 2 minus 12 over 2. So 54 plus 9 is 63. 63 minus 12 is going to be 51, right? So we're going to get 51 over 2. So that would be our answer for 10. But I hope you use this as a template for bounded integration. And what's really cool, I came across this the other day. I forget what problem it was. But when we sub in, so let's say we take, here, I'll just flip over. Let's say we're subbing in something. Excuse me. So let's do sine, let's do sine x plus 1. And we're integrating it from, let's just do 0 to 1. So what we're going to do here is we're going to sub in u for x plus 1. So dx is just going to equal dx. So when we sub this in, sine of u. So these boundaries are actually going to change. The way we do that is we take x plus 1 from 0 to 1, right? So if I plug in 0 for x equals 1, so that's my new boundary here. And then I'm doing 1 for x, so 1 plus 1 equals 2, and that's my new boundary up here. So now I can just integrate this, which is going to be, I think it's negative cosine u from 1 to 2. And now I can just plug in negative cosine of 2 minus negative cosine of 1 without having to plug this stuff back in, right? Because it's going to be the same thing. And I'll show you really quickly why that is. So let's say we kept this the same. So we have, oh sorry, this needs to be 1, 2. So let's say we have from 0 to 1 of sine u du. When I integrate it, it's going to be negative cosine of u from 0 to 1. So negative cosine of x plus 1 from 0 to 1. And so we're going to do negative cosine 1 plus 1 minus negative cosine of 0 plus 1, which is the same thing that we got up here. Sorry, this needs to be a 1. This needs to be a 2. It's the same thing we got there. Cosine of 2 minus negative cosine of 1. And I need a plus. I'll just put plus c on there. So again, these are the exact same thing. If you like doing this one, which is kind of fun. I like doing this one because it's a lot less going through this stuff. It's easier for me to just do the work over here, plug it in later. So if you like doing that, you can do it this way. If you don't like doing that, then you can do it this way. They're going to give you the same thing no matter what.